Hello dear students, very good evening to all of you guys and welcome to the BYJU'S exam prep. So in our today's session, we will discuss how we can find out the zero force member in a truss. You know that guys, in a truss, basically it is the combination of members and the joints, and in this particular type of structure, we have lot of number of joints as well as the member part. But still guys, there are some member which can have zero force or null force. But the question is, sir, if it is not taking any kind of force, then why we are putting it? So guys, there are two things which is very important for a truss member or for a particular member in any type of structure. That is basically to take the force, and second is the stability part. No doubt, each and every member of truss or whether it is a ridge joint structure, these members are capable to take the force as well as the maintain the stability of the structure. So let us suppose guys, if any member is there who is not taking force, but still we have to place it in the structure so that it can maintain the stability of the structure, right? So very good evening guys and welcome back, and let's understand how we can find out the zero force member. Okay, yes, you can ask me anything, there is no problem. Okay, and kindly share this session to other students so that they can join also. Okay, so let's start the session guys. Let's start the session and let's understand what are the various concepts by which we are able to find out the null force member or zero force member in a truss. So you know that guys, in the GATE examination and the ESE examination, this topic is very important because a lot of time we have seen you may find some question which is respect to this particular topic, right? It means null force member or zero force member. You have to find out how many null force members are there or how many zero force members are there in the truss, right? So there are mainly two concepts, but I will tell you one extra thing over here guys by which you are also able to find out the zero force member, right? That means we have three concepts to discuss so that we are able to find out the null force member in a truss. Okay, so let's understand one by one what are they basically. So first one is basically, let us suppose there are two member, let us suppose there are two member which is meeting at a joint. What is joint? Where the members are meeting, right? At the junction where members are meeting is known as joint. So this is nothing as basically our joint at which let us consider only two members are there, right? There are certain condition, I will write it down at the same time. Only two members should be there. Only two members are meeting at that particular joint right now. Okay, and let us consider the angle between these two members is theta, right? Let us consider this angle is theta. Now the condition for theta is greater than 0 degree and it should be less than 180 degree. If such condition prevails, then what happens? These two members will become non-collinear in nature. These two members will become non-collinear in nature, non-collinear members. But tell me guys, it is mandatory to have non-collinear member? Yes. I will tell you guys, when you have collinear condition, then what will happen? Then whether it is a zero force member or not, right? So we will discuss that particular point also. But let us write it down guys. In this particular case, theta cannot be equal to 0 and theta cannot be equal to 180 degree. If it is so, then these member will become collinear in nature. Now the question is, sir, what do you mean by collinear? What do you mean by non-collinear? Let me explain in detail what do you mean by collinear force member or non-collinear member force. Okay, so these are basically collinear member if theta is equal to 0 or theta is equal to 180, then the member will become collinear in nature, right? So our condition is theta should not be equal to 0 or theta should not be equal to 180 degree. If it is so, then member will become collinear in nature, right? Third point is, at this particular junction or at this particular joint, there should not be any kind of external support reaction. There should not be any kind of external loading also, right? That means at junction, no external loading and no external support reaction. No external support reaction should be there at the junction. Now, if such condition occur, then these two member will have zero force. Now, the question is, sir, how it is possible? So, let me explain it. So, this is basically our F1 and this is our F2. Let us consider. You know that, guys, at each and every truss joint, we have summation Fx is equal to 0 and summation Fy is equal to 0. And these are nothing as our joint equilibrium equation, right? So, let us use joint equilibrium equation to find out the force in member F1 and F2 also, right? So, let us write it down. Joint equilibrium equation. So, by using joint equilibrium equation, we can write summation Fx is equal to 0. Summation Fx is equal to 0 means F2 plus F1 cos theta is equal to 0. And the second equation we can write summation Fy is equal to 0. If summation Fy is equal to 0, so we can write here F1 sin theta is equal to how much? It is equal to 0. So directly can I say that, guys, the value of F1 will become 0. The value of F1 is 0. That means the force in member F1 or in this particular member is equal to how much? It is equal to 0. In the same way, we can put this particular value in the first equation. What we will get exactly? F2 is equal to 0 also. That means if two members are meeting at a joint and these two members are non-collinear in nature, that means the angle between these two members are in between 0 to 180 degree, and at this particular joint there should not be any kind of external loading, there should not be any kind of external support reaction, then these two members will carry zero force in the truss. These two members will carry zero force in the truss. Are you getting my point? Let me show you guys with one example so that you can understand this point in detail. Okay, let me show you one simple example to understand this concept. Let us consider this is our truss, this is one of the support, this is another support, and this one is hinge basically, and this is also hinge. Let us consider this is A, this is B, this is C, and this is D. And right now at this particular point C, we have a loading which is in vertical direction, and let us consider this loading is P. Now tell me, guys, in this particular case, which two member are zero force member? How you can find it out? You need to check this particular joint. Where you will get this particular condition, you need to check it. Okay, so kindly see this particular joint D. You can see here, guys, at the joint D, we have two member which are meeting. Okay, sir. These two member will not have any kind of support reaction or any kind of loading at joint D where they are meeting actually, right? And the angle between these two member is in between 0 to 180 degree. Right now it is equal to how much? 90 degree, right? That means this angle is in between 0 to 180. So that's why these two member will have zero force. These two member are zero force. That means it is null force member. No doubt these are not taking any kind of force, but these member again required for the stability part, and that's why we are not able to remove it in a practical condition. I hope all of you are able to understand this point. Yes or no? Please write it down, guys, quickly. Very nice, Balaji. Yes, DA and DC are zero force member, right? So I hope all of you are able to understand the first condition. But let us suppose, guys, if I consider theta is equal to 0 degree and theta is equal to 180 degree, then in that particular case, what will happen? Let's understand that point also. So let us suppose if theta is equal to 0 or theta is equal to 180 degree, then what will happen? It is very simple to understand. So let us consider this is our member F1 and this is our member F2, right? And let us consider the angle between these two member is right now it is equal to how much? 180 degree. Clear? If it is 0, that means the direction of both the forces will be same, right? But right now it is 180 degree. Let us consider it. Usually you can find such type of condition, but it is not possible to provide both the member in the same direction, right? So that's why we are not writing it. That means usually it can be 180 degree, right? Now in this particular case, if you apply summation fx0, summation fy0, you are able to understand whether these two members are zero force or not. Okay, so if I write here guys, summation fx is equal to 0, that means f1 minus f2 is equal to 0. So whatever force you have in f1, the same force is present in f2 also, right? Now it may be possible that f1 can be 0, then f2 will also be 0. It may be possible f1 cannot be 0, so f2 is also not 0, right? But it will depend upon the other joint from where you will get the value of f1 and f2. Then only we can justify it whether these members are zero force or not. Otherwise, you have to ignore such condition in the truss. Clear? Clear? So I hope all of you are able to understand the first condition which we have discussed. If two members which are non-collinear in nature, they are meeting at a joint where no external loading, no external support reaction is there, then these two members will have zero force. And now you are able to understand it very well. Okay. Now let us understand the second condition, guys. This is our condition number 2. Second condition. So in second condition, what we will consider, let us suppose there are three members which is meeting at a truss joint. Let us consider this is a truss joint where three members are meeting, and let us consider this is our F1, this one is F2, and this is F3. The angle of F2 with respect to F1 or F3 is basically our some theta, right? So right now we are considering with respect to F1. So this is basically our theta. Now guys, again you need to consider the same situations. At this particular joint, there should not be any kind of external load. No external loading, comma, no external support reaction. No external support reaction, right? No external loading, no external support reaction. And this particular angle theta again should lie in between 0 degree to 180 degree. That means theta cannot be equal to 0 degree. It cannot be equal to 180 degree. If such condition prevails, then what happens, guys? This F2 will be our non-collinear member. This one is non-collinear member. This one is non-collinear. And F1 and F3 are collinear in nature. What do you mean by collinear? If the line of action of forces are same, then it is known as collinear. If line of action are different, then it is non-collinear in nature. So the line of action for F1 and F3 is basically horizontal like this. So definitely this one is what? Collinear members. So these are collinear member right now. So the force in non-collinear member will become 0. Now how it is possible, sir? Let's solve it so that you can understand it. So guys, again we will apply the joint equilibrium equation at this particular joint. Let us consider joint O. So at this particular joint O, we will apply the joint equilibrium equation. Let's apply it. So joint equilibrium equation, right? We can write here, guys, summation Fy is equal to 0. That means F2 sine theta is equal to 0. F2 sine theta is equal to 0 and F2 is equal to how much? It will be 0. Now similarly we can write here, guys, summation Fx is equal to 0. If summation Fx is equal to 0, that means F1 plus F2 cos theta minus F3, and it is equal to how much? It is equal to 0. Now you know that, guys, the value of F2 is how much? F2 is equal to 0. If F2 is 0, so we can write here F1 is equal to F3. That means the force in member F1 and the force in member F3 will be equal and alike forces. What do you mean by equal? Equal means same magnitude. Alike means same nature, right? Not same direction, same nature. So these are equal and alike forces. What do you mean by alike? Let us suppose F1 is tension, then F3 is also tension. If F1 is compression, then F3 is also compression, right? So equal means in terms of magnitude, and alike means in terms of same nature. Nature means like compression or tension. Clear? Now I think all of you are able to understand both the concept, right? Okay. Let me explain the third one, right? Third one. Let me explain the third point by which you are able to find out zero force member in a truss. Let's take one example to understand the third concept. Let us consider this is our truss and the support of these truss are basically hinge, right? This is also hinge, this is also hinge, and let us consider there is a force which is placed at this particular point C and whose value is equal to P. This is A, this is B, and this is C. Now, what do you mean by truss member? Basically, truss member are capable to take the axial force, whether it is tension or compression, by their expansion or contraction of the member. If there is no expansion or contraction of truss member, that means there should not be any kind of force in the truss member, right? So let me explain it, guys, in detail. So right now, let us consider this is our truss member and this is our joint A and this is our joint B. Now tell me, guys, if I want to produce force in member AB, I need to have some joint displacement, right? So in which particular direction this joint can move? There are two directions, delta AY and delta AX usually. Similarly, guys, in this case, it will be delta BX and delta BY. Sir, it is practically possible to have zero force member? Yes, definitely we will have zero force member in the structure and we need to use it also. Why? Because to maintain the stability. It is not like that if you have zero force member, then you will remove it from the structure. You don't have to remove it. It is required for the stability part also. So that's why you have to place it. Clear, Shahid? Okay. Now kindly check this, guys. Let us suppose in this particular truss member, the length is L and A is cross section area and E is Young's modulus of elasticity. Now tell me, guys, how I can change the length of this particular member AB? By changing the value or by having some value of delta AX and delta BX, right? If these two values are 0, then this particular truss member will not have any kind of expansion or contraction, correct? So can I say that, guys, if delta AX is 0 and delta BX is 0, that means the net change in length of the member, is 0. If net change in length of member is 0, then this member will have also zero force, right? How it is possible? Let me tell you, guys. Do you remember one simple concept? If I want to find out the axial deformation by applying some axial force, so what will be that formula? FL upon AE is equal to delta, correct? FL upon A is equal to delta. Now in this particular case, let us suppose if this particular joint and this joint is not moving anywhere, this delta AY is also 0 and that delta BY is also 0 and delta AX and delta BX is also 0. Now tell me, guys, this member will not have any kind of change in length. If it is not having any kind of change in length, then this delta is 0. If delta is 0, then the value of F is equal to how much? Again, it is 0. Yes or no? Why? Because we can write it down. F is equal to A by L multiplied by delta, simply, right? So this particular value is how much, guys? It is 0. So ultimately the force in truss member is again 0. So please remember this particular point. If you have a truss member which is constrained between the two support, listen very carefully. If you have a truss member which is constrained between two support and the joint A or joint B is not possible to move anywhere, whether it is vertical or downward or it is horizontal or leftward or rightward, it doesn't matter, right? So if it is not possible to move the joint A and B, then the change in length in this particular member is 0. If change in length is 0, then ultimately the force in member AB is also 0, right? And this is the third concept which we need to understand to find out the null force member or zero force member. I hope all of you are able to understand. Shahid, Balaji, Rahul, tell me, guys, all three concepts are clear? Write it down quickly. Then we will have some question to solve. Guys. Very nice, very nice. So let's solve some of the questions. Okay. Please let me know the answer also. So this is a truss in the pin jointed plane frame shown in the given figure. The force in member BD. You need to find out what should be the force in member BD. Tell me, guys, there are 4 options you have, and please write down your option in the chat box quickly. What should be the force in member BD? Tell me, guys. So as we have discussed guys, whatever joint you are considering, at that particular joint you need to apply the concept. Okay. No, Shahid, it is not mandatory to have, means you always know that in case of truss, we don't have any kind of fixed support. Usually it can be a hinge, maximum hinge support, right? It is not 5000 kilonewton tensile. Reshma, C. Okay, yes. C is the correct answer. It is a zero force member, right? It is a zero force member. Now let me explain why it is zero force member in detail. Tell me guys, if I want to find out the force in member BD, then I can solve it either from joint D or either from joint B. That is my choice, right? But I will choose that particular joint from where it is suitable or it is easy to apply the joint equilibrium equation. Now tell me guys, if I consider joint D and apply joint equilibrium equation, that will be difficult for me, right? Why? Because there are three members which is meeting at this particular joint, and if I apply the summation fx0 summation fy0, all three members will have their component in both the equations, and that's why it is difficult to solve this particular member from joint D. But let us suppose guys, if I take the joint B, then what will happen? So you need to draw the free body diagram. How you can draw it? Kindly cut the members and apply tension force in each of the member. Tension means away from the joint, right? So this one is FBD, this one is FBC, this one is FBA. Now tell me guys, if you consider joint B, at this particular joint, there should not be any kind of load, any kind of support reaction, and the angle between these two members are 90 degree. That means this particular member will not have any kind of force. That means it is zero force member, and that's why C is the correct answer for the problem. Either you can apply the joint equilibrium equation like summation Fy is equal to 0 directly to get the answer. Clear? Right? Very nice, Balaji. So C is the correct answer for the problem. Now tell me guys, in this particular case, the concept which we have discussed, actually that is not applied. But if you apply the joint equilibrium equation, you will get the answer, right? So kindly see the problem and let me know the answer. The force in member AB is equal to how much? Tell me guys. The force in member AB. This is AB member. What is the force in member AB? D, none of this. D, none of this. Very nice, Reshma. What about other students? Please write down quickly. Shahid 0, Wali 0. Very nice, very nice. Balaji 0, very nice. So definitely the answer is 0, but it is not given in the option. That's why we have to take D as the answer. But let's understand how we can get the answer. So first of all, kindly break this particular joint from joint B, right? Kindly break it and try to draw the free body diagram again. Let us consider this is our one of the member. This is another member. This is our support reaction, which is basically 5 kilonewton. Correct? And let us suppose this force is FBA. Now what I will do guys, at this particular junction, it is not possible to apply the concept which we have discussed. Like two members are meeting, but at this particular joint, right now we are having some external support reaction. Then how you can consider the concept which we have discussed? It is not possible. But still we can find out the force in member AB. How we can do it, sir? It is very simple. You need to write summation Fx is equal to 0. Correct? So minus FBA is equal to how much? It is equal to 0 because there is no horizontal loading or there is no horizontal force other than FBA, right? So that's why FBA is equal to how much, bacha? FBA is equal to 0. And that's why our answer is D. D is the correct answer, right? Very nice. Let's move to the next question. What is the force in member AB? I think this problem we have already discussed in our example. So please let me know the answer quickly. We have already discussed this particular member, right? Write down guys, the force in member AB. Again, do not get confused. Do not get confused. You can solve the problem either from joint B or joint A. That is your choice. So guys, I will prefer joint A to find out the force in member AB, right? If you are saying sir B compression, that is a wrong answer. Why it is wrong? Let me explain. Tell me guys, if you consider joint B, then there are two members who can take the horizontal force. One is AB and second is this particular member, right? You need to write down the component of this member in the horizontal direction. Then how you can find out the force in member AB and in this member? It is not possible. So that's why kindly consider joint A and directly you will get the answer. So this is basically our FAB and this is some force F. Let us consider FC, FAC. So we'll find out the force in member AB by writing summation Fx is equal to 0 at joint A. At joint A. So ultimately FAB will become how much? It is equal to 0, bacha, right? And that's why our answer is D. D is the correct answer, right? D is the correct answer. Next question guys, this is a MSQ type problem. What do you mean by MSQ? Let me explain it. MSQ means multiple select question. That means you may have multiple answer. That means more than one option can be correct. So kindly see the question, kindly see the option properly, then put your answer. And this type of questions can be a risky one. If you are not able to tick all of the option, then you will not get the marks, right? So be careful while solving MSQ problem. Okay, kindly see the question. Which of the following are non-zero force member? Now this is the different one. You need to tell me non-zero force member, not a zero force member, non-zero force member. Non-zero force member, not a zero force member, right? So kindly see the option first and check it out. Which member will have force, right? That you have to solve. Do it guys and let me know the answer quickly. RH, okay, very nice. Which of the following member will have force? RH, okay, Valli. PK, okay. Any student who got the answer, anyone who got the complete answer. Be careful guys with the word which is non-zero force member, non-zero. It is not zero, right? Valli RH, Balaji PK. Let's see any other student who is able to solve the question. Please write down guys quickly. Write down quickly. And hit the heart sign also guys if you like the question, so that I can understand you love these type of questions also. RH only sir, okay, we'll check it out. Okay guys, let's solve this problem. So first of all we need to mark the members which we have to find out. Okay, so first one is basically PK, second one is ON, third one is RH, and fourth one is EF. EF is this. Okay, now we need to mark non-zero force member. So first of all, kindly see joint F. At joint F there are two members, one is EF, second is FG. So definitely this EF member will have zero force. If it is zero force member, then this option is not possible as our answer. Clear? Okay sir. What about ON? So again we will consider joint N and try to see NM and AN member, these are collinear. This one is non-collinear. At this particular joint there is no loading, there is no external support reaction, and the angle between these two members are 0 to 180. So that's why it is again zero force member. So ON is also not possible. ON is also not possible. If we talk about RH member, so vertical loading we have 6 kilonewton. So definitely 6 kilonewton should be applied in the upward direction in member RH. So that's why it will have some force. So we have to take it as an answer, right? Next one is PK. Now for PK, let's understand how we can find out the value for this. So first, this one is zero force member. This PL will be a zero force member. Now kindly remove it for your temporary purpose of analysis, right? First, I will remove this member for further analysis process. Now what you will do, guys, you will consider joint P and kindly observe member PD and member PM are collinear in nature and this is non-collinear in nature. So that's why PK will have zero force again. If it is zero force, again this is wrong. So only one member is there. Only one member is there which is non-zero force, that is C. C is the correct answer. RH. Next question, guys, again MSQ. Please read the statement very carefully. And this is the last question. Okay. Please read the statement very carefully, guys. And guys, let me tell you something over here. You can join me on my free class also, where we will discuss the problem of environmental engineering on a regular basis, where you will find the poll option so that you can give your answer in the poll, right? You may have some option on the display on your mobile. You can give the answer directly, right? And you are able to means you will know the score also and what rank you are getting as compared to other student. So my tomorrow topic will be solid waste, air pollution and noise pollution. If you want to get the link, I will share the link of my free class also on the chat box. So from where you can join it easily. How ON? Listen, it is very simple. Tell me, Shahid, at the joint N, we don't have any kind of external loading, external support reaction. So at this particular joint, only 3 members are meeting. And these 2 members are collinear. This one is non-collinear. So definitely it will be a zero force member, right? Okay. Let's understand the last question, guys. Member AC and BC will have zero force. Let's check it out. This AC, and this is our BC. So tell me, guys, AC and BC will have zero or AB and BC will zero? Tell me, guys, AB and BC 0 or AC and BC 0? AB 0 and BC 0, not AC, right? AB and BA, sorry, AB and BC is 0 basically. What about AC? It may have some force, right? इसके पास कुछ हो सकता है. Getting a point or not? Tell me, guys. Getting it? So that's why the first statement is wrong. First statement is wrong. What about next one? Force in member EC is P compressive. Force in member EC is P compressive. In this particular member, what will be the force? How we can find it out? By finding the value of reaction at support E. So first I will write summation moment at A is equal to 0. So this is again P force, P into 6, which should be clockwise, minus P into 3, which is anti-clockwise, minus V into 3, and it should be equal to 0. Correct? So we can write here, guys, 3P is equal to 3VE. So we can cancel 3 to 3, and ultimately V is equal to how much? It is equal to P value. It is equal to P value. Okay, sir. If VE is equal to P, then EC is equal to how much? It is also equal to P. How we can tell? How we can consider this? If you consider joint E, then you can write here force in EC member FEC. Then we have vertical reaction, which is P. These two members will have horizontal force like FEA and FED. Correct? Now I will write summation Fy is equal to 0. That means FEC plus P is equal to 0. So FEC is equal to how much? It is equal to minus P. That means it is compressive in nature. And that's why this option can be correct. This option can be correct, right? Now the next option is, if the load P is removed from joint D, if you remove this particular load P, then the force in member EA is 0. Listen guys, then the force in member EA is 0. How it is possible? Let me explain. Kindly observe the question very carefully. Roller support, hinge support, external loading P, and there is one internal member which should be like this. Now tell me guys, if I remove this particular loading, which is basically P, then these two members will become non-collinear nature and no external load, no external support reaction. So definitely it will be 0 and it is also 0. If this member is 0, then this member will also be 0. Why it is 0? Because we know that guys, at this particular joint, if I apply summation Fx is equal to 0, there is no other member which can take the horizontal force. So that's why if it is 0, then this member will also be 0. Getting a point? That means EA will be 0 force. Yes, it is correct. C is the correct answer. Now what about BC? The force in BC member is P tensile. We know that BC is 0 force member. So that's why this one is wrong. So only two options can be correct. B and C are the correct answer. I hope all of you are able to understand it very well. B and C are the correct answer for the question. Crystal clear guys? Any doubt if you have? Any doubt if you have? Crystal clear to all of you? Okay. So guys, you can join. Okay, let me share the. Okay guys, what you can do? You can join my AFRI classes also on a daily basis guys, right, at 10 a.m. So tomorrow again we have AFRI class in which we will discuss 30 question in 30 minutes. You can practice 30 best question from the solid waste, air pollution and noise pollution in 30 minutes, right? So on daily basis, you can join me at 10 a.m., right? At 10 a.m. Clear? So this is all about for today, guys. And thank you so much for joining the session. I hope this session is very useful for all of you who are attending live, right? As well as those who are watching it as a offline also. So guys, let's meet in the next one on 20th. We will meet again at the same time in which we will discuss how to find out the joint displacement in case of a rigid joint, right? We'll discuss it very well. Okay, I will share the link. Or either what you can do guys, you can join this particular Telegram. I will share the link over there, right? You can join this particular Telegram so that I can share the link of my AFRI class. You can join this Telegram, okay? Where I will share the link of AFRI classes also, okay? From where you will get it, okay? Clear? Okay guys, then let's close this particular session and let's meet in the next one in which we will discuss the further thing, okay? PDF, you will get the PDF of this session in the Telegram group also. In the Telegram, you will get the PDF also. Clear? So thank you so much guys. Let's meet in the next one. And I will share this particular PDF in the Telegram channel so that you can join it also. Okay guys, bye bye, take care and good day. And thank you so much for joining the session, right?